discussing about the Java features. So far we have completed discussing about 5 features, which includes portability, why Java is called as a simple programming language, why it is platform independent, and why it is called architecture neutral, and why it is often called as a secure programming language. These things we have discussed, and also we have understood the marginal difference between architecture neutral, platform independent concept and the portable. So these three concepts look similar, but there is a slight marginal difference. So that understanding is required. Like you can repeat my previous videos for the better understanding if you want to recollect, right? So again, today we are going to complete these remaining features. So let us understand why Java is called as object-oriented programming language. This is something very important to understand, because object-oriented is we call it as it is an approach, right? So when you have a problem here, for example, let's say that you have a problem to be solved. So this is a problem, just for the imagination. This is a small problem you have, and you want to solve this problem. So if you consider the computer programming, a problem can be solved by choosing a particular paradigm, right? So what do you mean by paradigm again? A paradigm is just an approach to solve a problem. If you want to solve this problem by using Java programming language, Java uses object-oriented paradigm. And you will see about you will exactly see about what is object-oriented programming. So Java uses this approach, object-oriented programming approach. And if you ask C program, like C program, can we solve a problem? Then C program is going to say, yes, I can solve your problem, but I am going to use a different approach. I am going to use a different paradigm. If you ask C++, say C++, can you solve my problem? Yes, I can solve your problem, but I am going to use a different approach. The problem can be solved, but the approaches can be different. Java is going to approach object-oriented paradigm, whereas if you check with the C language is going to approach it. It is going to give a different approach. C++ is going to give a different approach. So in the market, in the computer world, there are more than 1,000 programming languages. More than 1,000 programming languages in the computer world. And some of the new programming languages are getting built every year, and some of the languages are getting expired. On average, there are 1,000 programming languages, and Java is one among them. But all these programming languages that I am talking about is going to follow an approach to solve a problem, right? Each and every programming language is going to approach. It has its own approach to solve any problem, right? And object-oriented programming is one of the approaches, right? Sir, could you please elaborate me further? If you ask me, yes, I am going to elaborate that. First of all, let me categorize this. Let us understand where this object-oriented feature stands in the categorization. Let me import a small picture, and please pay some attention. This is really very important. I have downloaded this picture from from Google. Of course, it is going to make some sense. It talks about programming paradigm, right? If we see, this programming paradigm is categorized into imperative and declarative. And again, under the imperative, it has further categorized into two types: procedure-oriented, object-oriented, functional and logical. So these are the approaches. Previously, I have just mentioned that to solve any problem, a particular programming language is going to follow an approach. These are the approaches that any programming language can choose. We talk about Java. Java is standing here. Java has chosen object-oriented programming approach, right? And C++ also is following the same approach, object-oriented programming. And if you talk about C, it is going to solve the problem by using procedural-oriented. Talk about Lisp is a programming language. It is going to use functional approach. These are the logical approaches. So if you talk about all the programming languages that is available now in the computer world, each and every programming languages has its own approach to solve a problem. So since we are talking about Java, Java is following object-oriented paradigm. Simply, I can say that Java is just following object-oriented paradigm. This approach is being followed by Java, right? Java follows object-oriented programming paradigm. As simple as that. So to solve any problem, Java follows object-oriented programming paradigm. So now we will have to understand what is object-oriented programming paradigm. So that understanding is required, and again, this object-oriented programming concept is classified into many categories, like the way this programming paradigm. So it is classified into some categories, isn't it? Because object-oriented programming is a combination of many concepts, like encapsulation, polymorphism, class, object. So it is almost, it will take, I mean, if you complete this, 70% of Java is going to get completed. Right? So I'm going to give the brief understanding about what is object-oriented and why Java is chosen, Java's preferred object-oriented paradigm. What Java says everything is an object. Everything is an object in Java. If I say object is nothing but you can understand it like, for now you can understand it like a memory allocation. Everything is an object in Java, right? So we can also say that if you take the real-time examples or real-world examples, every physical entity, every physical existence is an object. Let us say that laptop is an object, the pen that you're using is an object. Every existence, every physical things that you are that is visible and that is sensible, called as object. Visible and sensible, right? Likewise, in Java, the programming language says everything that you write, every memory allocation is an object. Every memory allocation is an object. Let me elaborate this. So, what is an object? Let us say that you want to construct an house. What you want to do? You want to do what? You want to construct an house, right? So you don't construct an house directly, isn't it? So before even starting, before even you think about constructing an house, you will approach an architect, right? What architect does? He will make a plan, or he will create a design. Depends upon the land that depends upon the area of the land that you want to that you want to prepare constructing on a particular land. After the land acquisition, he is going to give a design as per the area of the land, right? So it is called as a pre-construction phase, which is also called as a planning phase. So in the planning phase, so this is the physical house. This is not how the plan is going to be. The plan looks like something like this. So on a sheet of paper, there will be there will be some diagrams, and it has some illustrations like this is going to be the bedroom, this is going to be the hall, somewhere around southwest it is going to be kitchen. This is a simple demonstration of a plan, and somewhere here there is going to be a study room, something like that. So this is going to be an entry. This is how the actual plan looks like, isn't it? This is going to be an entry. So this is a planning stage. Planning stage is what? It is just a design. It is an imaginary thing. It is not existed in the reality. It is an imaginary thing, so that we can understand this is how the house is going to be in the future. As soon as the construction starts, each and every day you are going to discover that house is getting constructed, and at last the final output is going to be the complete physical house. Right? The planning phase. The planning phase is done by the architect, and architect is going to give you the snippet in the sense a small illustration about how the physical things are going to be, like how many bedrooms it is going to occupy, and size of the area of the hall and the area of the kitchen, things like that, right? And a parking area. You get all this information in a particular plan, right? So if you want to convert this analogy into the real-time example, not in the real-time example, directly to the Java programming language, the things that you plan in the real world is something like the classes that you create in Java. It is similar to the classes that we create in Java. In Java, this concept of planning is nothing but creating a class, right? You have to blindly recognize that when you are trying to build a class in Java programming language, or when you are trying to develop a class in Java, developing a class is nothing but planning. You are planning something. You are creating a plan. This is how we can represent a plan in Java. The real world planning is nothing but the architecture things, and in Java the planning is nothing but a class. So the class is going to have information. What kind of the plan has information like the number of it can have, see, you must understand here, this understanding is required. What I'm trying to say is the information that the architecture is going to provide you. What information is going to provide you? It's not going to provide you only about the area it is going to occupy, things like that. It's going to provide information like how much time it is going to take to construct this, how much time, timing information, expenses, or we can say that expenses. I can say expenses, how much expensive it is going to be, and information about the raw materials, how much raw materials it is going to consume, and the time information, raw information, things like this. All the things related to plan. These are the things related to planning. So time consumption, expenses, as well as the raw material that is going to consume, things like this. There can be a lot of information. So these are the main information that can be categorized under the planning. Likewise, in the class, you have only two information. Only two information you can specify in a class. What are those two information if you ask me? First information is you can have properties. Second information is you can have behaviors. We'll understand about these properties and behaviors going forward. So when you take a class, you have to think blindly like the class is going to have only two information. One is properties, second one is behaviors. Properties are nothing but variables or data. Simply think that property, just replace the properties with data, variables. Variables are also called as data. Behaviors, if you want to describe about the behavior, you can just think like behaviors are nothing but methods or functions. The main function is nothing but a behavior. Right? User defined functions is nothing but a behavior. So these two things gets encapsulated into a class. Right? Whatever the class that you're writing, class is going to have two information. One is properties, second one is behaviors. The properties are nothing but variables and data. Behaviors are nothing but the methods or functions, I can say. Function. These are information that gets encapsulated into a single entity. This is called planning. Right? If you convert the architecture planning, and this architectural planning looks similar like the particular Java class. And one more thing. So this is called as class, and this is how the class can be imagined from the physical perspective or from the real world example. When you talk about class, you just think about class is nothing but a plan, right? So now after planning, this is the pre-construction things. I mean, the construction is not yet started. These are the things that happens before even starting the construction. So these are the pre-construction things. So after construction, a new house is going to be. The house will not get appear directly, isn't it? As soon as the plan is evolved or plan is displayed, house will not just appear from the sky. Right? House has to get construction has to get started. Foundation, we have to start foundation. We have to make sure that we are laying the foundation stone. After laying the foundation stone, and we have to build the foundation, and on top of the foundation, the house will be constructed on the top of the foundation. Things like that. It will take some time, right? And after implementing this plan, this is a planning phase. Once the plan is implemented successfully, once you are able to see the plan that is getting implemented successfully, or it is completely visible to your eyes, the form of physical entity, you can see now. No matter how much time it is going to take, one or the other, you are going to see this constructed house. This plan is coming into the reality, right? Planning things are coming into the reality, not immediately, after some days. If you want to replicate this, or if you want to reproduce this in the Java programming language, you say it as objects. So the similar term that you use in Java is what? Object. Object is nothing but the plan, the physical plan that is coming into the reality, the actual picture. Likewise, when the class is converted, or when you are creating an instance of a class, when you are actually trying to use that class, when you are actually trying to produce something from the class, or when you are actually trying to replicate something from the class, they are called as objects. In Java, they are called as what? Simply they are called as objects. This is how object looks like. So object is like nothing but what? Memory allocation. This is an object. Since it is a single object, let me use the singular word object. Right? This is an object. Now, if you focus something, in future, let us understand that if your friend or someone from your relatives, if they are actually liking your house, no one is going to say that they like your house, but still, if relatives are good, they are going to say, yes, I like your house. If they like your house, what they are going to approach the same architect, or they can even take a copy of this plan, so that they can build the same house, they can replicate the same house, right? So you can create a multiple copies from a single plan. You can create multiple copies. But one thing, even though if you are creating multiple copies, but the location of the house, let us say that I like this plan, I want to use this plan. I can use this plan, but I cannot use the same location. I have to use a different location to construct the house. Let me say that I am living in Chennai, and you are living in Bangalore. I can construct the same house in Chennai. If Ganesh is living in Andhra, he can construct the same house in Andhra. If Samhita is living in Chennai, he likes the plan, she can construct the same house. Locations are different. So a number of same kind of house can be created in different locations. Each and every house is going to have a different house number or different addresses. This address 1, let us say address 2, this is address 1, this what? Address 3. Likewise, I can, from a same class, I can create n number of objects, not one object, I can create n number of objects and n number of memory allocation. Right? This is how, this is what the object oriented, right? Object oriented programming language is nothing but everything is converted into objects. The class, the properties and behaviors that you are containing in a class has to get converted to object. You can perform manipulations on this object. The manipulations can be performed. Again, if you ask me what are the manipulations, sir? What kind of manipulations you are talking about? Manipulations are nothing but handling the data. The data cannot be fixed, right? The data keep changing. Temporary data are going to change, because let us understand in this way. Let us say that this is my bank balance object. Let us understand that this is my bank balance object. Do you think my bank balance is going to be intermittent for a long time? It is going to persist just like that for a long time? Depends, it is variable. Today it might be You can see some amount tomorrow, there will be some other amount, because we are consuming the balance. The balance is not going to be fixed. This is variable. Data manipulation is happening every day, right? That's why if you talk about an house, do you think that house is going to be same? We will do some internal modifications, right? Internal design. We have our own internal design. Even though the number of houses are created, the objects inside this house, the things that is contained in this house is going to be different, because you may be having two air conditioners and your friend might be having one air conditioner. He is going to have no air conditioner, no ACs. Internal things are going to be different. Likewise, object manipulations can be performed every time. It is not going to be the same. Data is not going to be same. Data can be varied from time to time. Right? So what is the takeaway, sir? So we have understood what is planning, what is like constructing. It is simple, it makes simple. And what is a class? Because class is the direct representation of the planning, and the object is a direct representation of the construction. Class, object, constructing an object from a class. Constructing an object from a class means constructing a memory. How does it it is okay, but what is object oriented programming? What is object oriented paradigm? So in Java, as I have already said, to manipulate any data or to use any behaviors, you need to construct an object. Every time you need to construct an object. For example, let me take, I have a class called, I have a car class. The name of the class is car, it's just a plan. So again I am saying, when you think about the class, think about, right, you are designing a plan. Right, so I am going to design a car class in the sense I am going to, like, create a plan to design a car. Right, car, let us take two properties. One is name, second one is what could a car have. These are the properties. Properties are something that can be identified. You can identify something with property means, what does it mean? You can identify the car with the name. I mean, BMW means name of the car. Color means you can do the actual identification. They are called as properties. But behaviors are something that has to be included in methods. Let us say that void speed. It is a behavior, right? And what can be the another behavior? Void break. Break is also a behavior. Things that you experience is called as behavior. Things that you experience, things that you identify is called as properties. So this is my car class. In my car class, I have what? Two properties. Properties represents what? Data. Data. Actual data is what? This is the actual data. Name of the car and color of the car. Right. Behavior is what? Speed of the car and braking. Car braking. I have simply mentioned as brake. The power of braking, I can say. Speed and power of braking. If this is a car, this is a common noun. I can say the pronoun, right? This is just a car. I can have many cars. If I want to create an object for this car, yes, you can create an object. This is the plan. This is the plan. In my plan, I have name, I have color, I have speed, and I have behaviors and properties. If I want to convert this plan into reality, let me create objects. Let me create three objects. In this case, 1, 2, 3. So let me write car 1, car 2, car 3. Three objects are created. So the car 1 is going to have what? Name, color. So in this case, I'm going to recreate or replicate this plan, replicate my plan into the reality. So that I'm going to keep the name of the car as BMW. It is just a car, but the design principle is different. With this plan, I'm creating a BMW car, and I'm keeping the color as red. Right? In this case, in my second object, I'm going to keep the property name as Audi. The color is going to be something like yellow. And in this case, the name of the car is what? BMW, Audi, let us say that Maruti. Color is white. This is nothing but object 1, object 2, object 3. All these objects are created from the classes. That's why object is called as what? Instance of a class. You can actually create the memory. I mean, memory in the sense of these are something that is existed. These are the physical things. In Java case, physical things are nothing but the memory. Memory is getting allocated for each and every object from the class. Class is a plan. Objects are nothing but the construction of the plan. Right? Objects are instance of a class. So again, question, if you see the question, why it is object oriented? Whatever you do in Java, you have to do that with a class. And if you just create the class, it is not going to help you out, because class is just a kind of a planning. Right? If you want to convert these classes into the reality, if you want to actually perform any manipulations on a particular class, if you want to make sure that this class is getting things done, you need to create the object. What you are doing to do, you are creating an object. That's why it is always called as object oriented. So this is making sense. You don't do things with a class, because in the interview question there are chances that you will be asked a question like, will the class consume any memory? What? The question is like, will the class consume any memory? The actual direct answer is straight answer, strictly no. Class will not occupy any memory. Only the object, whenever you are creating an object, this object is going to occupy the memory. You can create a number of classes, it will not occupy any memory. Only the objects. As soon as you create a core one object, it is going to consume memory, it is going to consume memory, it is going to consume. In this case, by this we can say that it is object oriented. Object oriented, because memory consumption actually happens after creating an object. Right? Secondly, firstly is memory consumption. Secondly, you can say it is object oriented because if you want to manipulate with the data, you can manipulate the objects. Not the objects. You can perform manipulations only with the objects. That is why it is also called as object oriented. Right? One is object creation and second one is object manipulations. Right? So everything is linked to, that's why objects are everything is linked to the object. That's why everything in Java is object. Right? Hope it is making sense, right? So to solve any problem, again I'm coming back to the first question. You are given a problem A. If you want to solve that problem by using Java, you will use what? You will use object-oriented approach. What is object-oriented approach? You can simply say Java follows object-oriented programming paradigm, because everything in Java is an object. Right? In order to perform any manipulations, you need to perform manipulations. You can perform manipulations only on the object, only on the objects. That's why it is called as object-oriented. Then again, what is object? Object is nothing but a memory block, a memory allocation. What is a class? Class is a container that is going to have properties and behaviors encapsulated into a single entity. Right? So if you go back to real-time example, planning contains many things, many categories. Apart from this, there could be many things. You can keep a big list. Keeps going. Planning is something not limited. It is a very big thing in the reality. But in Java, there are two things you have to think about: properties, behavior. That's it. Apart from that, nothing. A plan contains properties and behaviors. Properties are what? Data. Behaviors are what? Methods. Right? Just type S in the chat box if it is making sense, so that we will continue further. Okay. So I hope why it is called object oriented thing, because everything in Java is an object. So let me give you a small theory. Java, everything is an object. And the class is an container that encapsulates the data and the behavior. In this case, you can say properties and the behavior. Data, behavior, or you can also say properties and the behavior. Data as a single entity on top of which you can create an object and perform the manipulations. Since it is following the object oriented paradigm, it is called as object oriented programming language, OOPL. As simple as that. OOPL means object oriented programming language. As simple as that. This is the simple explanation. And you can also take this into the consideration. Even C++ is also object oriented, and these languages are following a different approach. Right? Procedural oriented. C is following procedural oriented. This is something a different approach. And functional Lisp, Lisp is a language, and Scheme is a language. Conjure is a language. These are the languages that has its own approach to solve a problem. So Java and C++ are going to follow the same approach, which is object oriented programming approach. Nothing but objects. Right? Nextly, we will discuss about this thing is over. Nextly, we understand what is multi-threaded. Right? Let me save this and open a new thing. So now we will understand what is multi-threaded. So this is something very interesting. We have just completed object oriented. Now let us understand what is multi-threaded. Multi-threaded. Why Java is multi-threaded? So before even understanding multi-threaded, we will try to understand what is multitasking, what is single tasking, and what is multitasking. Right? So let us say that there is a piece of work. There is a piece of work, and this piece of work is assigned to a person. A piece of work is assigned to a person A, right? And is going to complete this work in 10 days. 10 days, right? A piece of work is assigned to a person A and is going to take 10 days to complete this work. This is the first case. This is called as single tasking. This is the first case. Second case, what if you are assigning the same work? What if you are going to assign the same work to two persons? Same piece of work, now we are assigning it to two different persons at the same time. Person A, this time person A and person B are going to work on this assignment, which is work, right? So let us say that two persons are taking up this work. Not exactly they are going to complete in 5 days. Maybe they may take 5 to 6 days. So this is the second thing. This is what multitasking. 5 to 6 days, right? So when the work is shared, like when you have a work and if you are assigning that work to a particular person, of course the person is going to take as long as he can, or as per his capacity, he may be completing it in 10 days. Let us say that it's going to be 10 days on an average. Same work is assigned to two persons now. On an average, they are going to complete in 5 to 6 days. The more you keep adding the persons, the time consumption is going to be reduced, isn't it? In this case, the time is what inversely, what we call it as directly proportional to the number of persons that you are assigning. A work is when the work is assigned to, if you increase the number of persons, the time consumption is going to get reduced. So it is inversely proportional, not directly. Time is getting reduced when the persons are getting increased. Right? So when you keep adding persons, the time consumption is going to be reduced. And same, you can, this is the analogy that you can replicate in Java. Like how do we replicate in Java? In Java, usually when you are creating a program, when you are designing a small program, let us say that class test, and in this class test you are going to have the main method, class test and your main method, and in this main method you are having at least 1000 instructions to be executed, like instruction 1, instruction 2, like that you have 1000 instructions, right? So in every class there will be a person in the sense arbitrary, I'm saying it as a person, but when you talk about the Java programming language, we call it as thread. Thread is responsible to execute each and every instruction. So this thread is just like a person here. Thread is just like a person. The purpose, the job of the thread is to execute each and every instruction. Let us say that to execute one instruction is taking 1 minute. To execute all the 1000 instruction, it is going to take what? 1000 minutes. Isn't it? 1000 minutes is going to take. And after 1000 minutes, the program will be terminated normally. And it took 1000 minutes to execute this piece of code just for an imaginary purpose. But Java is an option. Java is an option, right? What it has? You as a developer can assign another person. You can assign any number of persons. So if you talk technically, in Java, you can build any number of threads. So main thread is a default thread. It is the default thread that is going to execute all the instructions. But apart from the main thread, you as a developer, you have an option to generate your own threads, own user-defined threads, right? And after creating your threads, you can just give an instruction saying that, hey, thread 2, can you execute instruction starting from 500? And you can assign some task like, hey, thread 3, can you execute the instruction starting from 800? So you are dividing the task, you are dividing the instructions. So the main thread is going to execute first 500 instructions. The second thread is going to execute the instructions from 500 to 799. The third thread is going to execute from 800 to 1000 instructions. Task has been divided into 3 categories, and each and every thread is going to work on the tasks that we have assigned it. Right? These things are nothing but what? Multi-threading. And in Java, technically we say that this has parallel execution. So parallel execution is nothing but assigning a task or trying to make sure that multi-threading is achieved. The developer has an option to create a number of user-defined threads, and each and every thread can be assigned with a specific task or specific instructions to be executed, so that all the 3 threads will work independently. This thread will have its own task, and this thread is going to have an independent task, and this thread is going to have an independent task. So because of this, what is the outcome? Because of the multi-threaded concept, what is the outcome? What could be the outcome? The outcome is very simple. The time is going to get reduced. Whenever the time is reduced, when you find the reduction in time, you also find that there is an improvement in the performance. Because time is an entity that is going to talk about the performance. When the time is reduced, the performance is increasing. Right? So reduction of time, how the time will be reduced in Java, you have to appoint multiple threads. That is called as multi-threading concept. The concept is called as multi-threaded concept. So each and every execution flow is called as what? Thread. Thread is going to execute each flow of execution, each instruction. You can assign the specific instructions to this thread, and some specific instruction to thread, some specific to this thread, and some instructions specific to this thread. So each and every thread is going to work independently. And again, there should be no dependency between these instructions. Each and every instructions are independent instructions, right? You have to make sure that all the instructions are independent instructions. There should be no dependency. What do you mean by independent instructions? If you ask me, another example I can give is, let us say that in your household, if you are trying to clean dishes, there is no required to follow any pattern or what we call it as any sequence to do dishes. You can clean as per your convenience, isn't it? But for cooking, you have to follow a particular pattern, right? You want to cook something, obviously you have to follow a pattern. What pattern is that? You have to make sure that, for example, if you want to cook something like biryani, so I'm taking the example of biryani. So biryani, first you need to cut onions, then you have to pour the oil, fry onions, and after that add masalas, then add chicken, then add some water, and add rice. Keep it in the cooker. These are the step-by-step procedure to perform a cooking. Right. So in this case, cooking has to be taken care separately by one person. Right, because it is completely independent. Right. And let us consider another task, cleaning task. Cleaning has to be taken care by a different person because that is independent, because you can clean as well as at the same time you can cook. It's not going to affect each other, isn't it? Both are different tasks. You can perform these two tasks at a time. It is not going to affect. The third task is what? You can say cleaning and then eating. So eating should be done by the both persons, person A and person B, right? Can be done only after cooking, isn't it? Dependency is there. First complete cooking, then eating. Cooking first, then we can eat. Do you think we can perform these operations vice versa? Not possible. Dependency is there. Okay. So this is a first task. Task 1. Complete this task, then the task 2 can be started. You cannot eat without cooking. Right? But this is something, cleaning is independent. You can clean the house. Even before eating or after eating, the house can be cleaned while cooking, before eating or after eating. Right? In this case, if you want to implement this to Java, You have to identify the independent task. This is an independent task. You can assign a thread to the independent instructions which has no dependencies. That is what I am talking about. This is something that is independent because it is not operating on any dependencies. It can perform this action independently. So this cooking task and eating task is dependent to each other. So this task needs to be executed. So these two tasks should be assigned to a main thread by default. The main thread will execute this cooking, then the main thread will execute eating instruction. Firstly, main cooking instruction, secondly eating instruction. Meanwhile, you can appoint another thread which will take care of cleaning. Right? This is concept is called parallel execution, and parallel execution is assured if the instructions or the statements that we want to execute has no dependencies. If it has dependencies, the dependent instruction should be executed only by the same thread. The independent instruction can be appointed with a new thread so that the parallel execution can be performed. When the parallel execution is performed, what does it mean? Time will be reduced. When the time is reduced, again, what is an advantage? Performance will be increased. So if you see this analogy, like it is very clear that multi-threading is an advantage in Java or not. When you say it is multi-threaded, it means it's an advantage. Right? You can write a big set of lines with what we call it as 1 lakh statements of code or 1 lakh behaviors, 1 lakh instructions. You can appoint any number of threads, right? And the time will be reduced and the performance will be increased. Just imagine if you're trying to open Facebook, and if you Facebook, just if you click on Facebook, before even clicking on it, we are finding it is open, isn't it, nowadays? But previously, when we are using 3G SIMs and 2G SIMs, first time if you try to even open an image, it will take at least 30 seconds to 1 minute, right? So the time consumption is more. If the time consumption is more, we are concluding that the performance is less, right? So when you are developing an application, you have to make sure that the time and the performance, this parameter should be considered. You have to give a top priority to the time and the performance, right? Then only the application is going to be the user-friendly application. In order to achieve that, we need to implement this multi-threading concept. But to make it further clear, if there is no multi-threaded concept in Java, for example, we have a laptop or we have a system, right? This is a system. This is how it looks like. Just imagine I have 4 tasks to be performed. First one is I need to open something. I need to browse something. And second task is what? I am listening music. And third task is sending email. Fourth task is updating antivirus. There is no multitasking. Firstly, what I will do? I will browse. It will take 1 hour. Just imagine. Nextly, I will listen some songs. Let us say I am listening 5 songs. Right? It is going to take half an hour or something like around half an hour, right? After that, I am sending emails. It will take at least half an hour. Then I am updating antivirus. If all these things are performed sequentially, what is the outcome? Time consumption is more. Right? So multitasking is since the multitasking concept is there in the system everywhere, not in the system, mobile ones everywhere. I can perform browsing at the same time. I can listen to the music. While doing this, I can also do this. The background antivirus is getting updated. Right? All these things will be completed in 1 hour. Right? So you don't think that multitasking is something that is a boon to the Java programming language? So Java programming language internally designed to get the concept of multi-threaded, which means there are some APIs that we can add in the programming languages. The APIs like runnable, we will see these things in the future. That will be very interesting. Runnable and thread class. So some APIs are there in the runnable interface and the thread class. With this, we can create our own threads, perform the execution. This is what it means to be, why Java is meant to be a multi-threaded programming language. Hope this is making some sense. Just type S in the chat box if this topic is giving some clarity. Okay. So let me give you a small theory. This theory, this code is just for the interview purpose. I thought to complete all this, but I don't think it will be completed by today. We need one more day because these things are very really simple. The performance, dynamic, distributed, compile, enter. These are going to be very simple. So this needs some understanding. Java is multi-threaded because it has many internally. It has many APIs internally that enables a developer to design a program that could be handled by different threads for parallel execution. That's why this called as multi-threaded programming language. This could be fine for the interview purpose. And if you ask me about the multi-threading concept, this is going to be a very big topic. We do not have to worry about it. I'll keep it very simple, right? So this is something that is within our syllabus, and this topic is going to be very interesting. I hope this is making sense. And the next topic, still we have time, and next concept is what robust. Simply, I'm going to give the definition. We will continue about the robust tomorrow. What do you mean by robust? What does it exactly mean? What is the actual dictionary meaning of the robust? If you ask me, robust is simply, in simple words, we can say that strongest, we can say. Strongest is the strong is the word that I would prefer. And we can also say that healthy. So does it mean that Java is healthy and Java is strong? Yes, it is strong. It is healthy. But how do we represent that in the computer world? In the computer world, when you cannot say healthy, you cannot say strong. So you use the term robust. What does it mean is Java is strong because of these features. At the same time, Java is strong because, not because of this feature, just because if you want to break the Java programming language, it is very, very difficult to break the Java programming language. You cannot fail the Java programming language. That's what I mean. You cannot. It is very difficult to fail the Java programming language, Java programming behavior. To fail the Java programming language. It is impossible. If you ask me, sir, this is the exact definition for the robust. Yes, this is what the thing is. We will understand it further tomorrow. Why it is very difficult to break. We know what, and we have to understand.